Okay, so thank you. This is the third and final part of our lesson on non-metric conversions, and it's going to be on rate conversions. So rates, we typically have a measurement per unit of time. It could be a distance per unit of time or a volume per unit of time. And so we're going to be including time factors into our conversions. Some equalities that you need to know are a minute 60 seconds, an hour 60 minutes, an hour is 3600 seconds, and a day is 24 hours. All of these are also included on your conversion sheet at the bottom should you need to look them up at any point. So let's get on to the first example. We want to convert 25.0 kilometers per hour to meters per minute. You'll notice I've written the kilometers per hour as a fraction here instead of with our common slash like kilometers per hour with we might see it written something like that. Okay, the reason why I want to do that is because I want to draw your attention to the numerator and denominator, this idea that kilometers per hour is kilometers over hours. And when we're converting to another unit like meters per minute, what we're doing is we're going to see the same type of distance, same type of unit. So a distance unit in the numerator and then a time unit in the denominator. And so what we have going on is we've got two conversions happening at once. We're converting from kilometers to meters, and we're also converting from hours to minutes. And as long as we recognize that we've got those two different conversions happening, then everything we've learned so far about conversion factors is going to help make this conversion really straightforward. Okay? So the other thing is when I set this up, I'm going to set up my initial measurement as a fraction where I have 25.0 kilometers, and then the per hour I'm going to put in the denominator. Okay. So we're going to do our distance conversion first. We know we're going from kilometers to meters. We know how to convert between kilometers and meters. We know 1 kilometer is 1,000 meters. And I set up my conversion factors so that the units cancel. Awesome, easy peasy. So the next thing I'm going to do is my time units, and I've got to go from hours to minutes. Now, we just have to be a little bit careful here. Remember, we want our units to cancel. So when I'm filling in my units, I'm going to put hours in the numerator because I've already got an hours in the denominator. So to balance it out, I need to put the hours in the numerator. And so the conversion that I'm going into is minutes goes in the denominator. I know 1 hour is 60 minutes. Boom. I've got my conversion factor set up. I'm going to put 25 times 1,000 divided by 60 into my calculator. Press equals, and I get an answer of 416.6666, and this is going to be meters per minute. I round to 3 significant digits so that my significant digits in matches my significant digits out. Awesome. So things to keep track of is making sure we set up our conversion factors so that the units cancel, and making sure that we know what conversion factors we need in the question. Let's try out the next example. So a car travels 85.0 kilometers per hour. How many feet does it travel in 1 second? So I'm going from kilometers per hour to feet per second. Okay? My distance measure is going from kilometers to feet, and my time unit is going from hours to seconds. Let's check and see if we have the conversion factors we need. First, kilometers to feet. Can I go directly from kilometers to feet? No, but I can go from kilometers to miles and miles to feet. Awesome, that'll be the path that we choose. So going back to our work, we're going to go from kilometers to miles. Oops. and miles to feet. Okay, and then for hours to seconds, sure, we can go directly from hours to seconds. We know 1 hour is 3,600 seconds. So let's set up our problem. We start off with 85.0 kilometers per hour, and then we're going to convert from kilometers to miles. 1 mile is 1.6093 kilometers, and then I'm going to go from miles to feet. 1 mile is 5,280 feet. Okay. Next, I'm going to go from hours to seconds. When I'm setting up my conversion factor for time, again, I'm setting it up so that my units cancel, that I can see that cancellation happening between my hours, and I know 1 hour is 3,600 seconds. Okay. When it goes to entering this into our calculator, we're going to put 85.0 divided by 1.6093 times 5,280 divided by 3,600. We press equals and we get an answer of 77.46639,326. And our units would be feet per second, or 77.5 feet per second. Okay, and we can start seeing in these more complicated conversions how using a conversion factor method, which may have seemed unnecessary when we started with metric conversions, really helps us and gives us one system to use for all of these different conversions. Okay, so next step is for you to try this out on your own. And you've got 2 practice problems here. The first one is converting 12.5 kilometers per hour to meters per second. And then the second one is you've got 30.0 gallons per hour to liters per second. So pause the video, try this out, and then you'll check your answers. Okay, so your answer should work out to 3.47 meters per second and 0.00315 liters per second. Okay. So the same technique for converting rates can also be used to convert density for density conversions between metric and non-metric units, or vice versa. So if we think about density is always a mass per volume, right? And so if I start off with 5.18 ounces per cubic inch, and I want to convert to grams per cubic centimeter, what I have going on is a conversion between a mass from ounces to grams, and then I also have a conversion in volume from cubic inches to cubic centimeters. Good thing is we've done both of those types of conversions before. We just have to figure out how to set it up. Okay, you may recall that for mass, we don't have a conversion factor that lets us go directly from ounces to grams, but I can go from ounces to pounds and pounds to grams. Okay, so I can write those conversion factors in. My conversion factor from ounces to pounds, 1 pound is 16 ounces, and then my conversion factor from pounds to grams. Next, we have our conversion factor from inches to centimeters. We know 1 inch is 2.54 centimeters, and I'm putting that conversion factor in brackets because it's cubic inches to cubic centimeters. I'm going to have to convert to cube that conversion factor. So to do a density conversion like this, I put my initial measurement in, my 5.18, divide by 16, multiply by 2.5359, and divide by 2.54 cubed. Pressing equals, this comes out to 8.9613222327 grams per cubic centimeter, rounding to 3 significant digits. it's 8.96 gram per cubic centimeters. Okay, so check that out. Try out the following homework problems. There's lots for you to work through. I think there's 25 questions in total. If you have questions, send me an email to schedule a time to chat, or drop into any of my regular scheduled office hours. Okay, take care, and we'll talk soon.